Welcome to the Mission Critical Applications Requirements session. My name is John Madden. I'm an engineering technologist here at Dell. Interesting fact about myself, I've been on the PowerMax team for over 31 years, and I'm currently a member of the PowerMax product management team. During today's discussion, we'll first be going over the definition of a mission critical application, what they are from a user's perspective. Next, we'll be talking about what the mission critical applications, where they actually run, what business verticals and their impacts. And finally, we'll be talking about the requirements of these mission critical applications. So what is the definition of a mission critical application? And very simply put by our users, these are applications which can incur no downtime. In fact, downtime is just not an option for a number of reasons. A couple of examples are a financial penalty or regulatory action being taken against a company in the case where they're not meeting their performance SLA. In the case of a loss of life, potentially an extreme case, when your medical records are not available during a critical time in your care treatment. If we take a look at who has these mission critical apps, who runs them, typically what we think about is the largest businesses and organizations of the world. Top 10 healthcare companies, top 10 US banks, 95% of the Fortune 100. This is not surprising to any of us at all. If you start looking into why they're so mission critical, let's look at the banking sector for a second. How many of us today are completely cashless? We walk out of our house with a credit or debit card in our hands, and we fully expect those transactions to occur real time, whether it's buying gas for our cars or actually going off and getting a coffee at our favorite coffee shop, right? The transportation industry, we think of a lot in similar ways. What comes to mind is the airline reservation system. How many of us have been using that are not happy when we can't make or change our reservations, right? But also in the transportation industry, more personal, is how many of us today use a mapping application on our phones as we're driving down the road between point A and point B and look for real-time directions and traffic indications. And more recently, power companies and satellite communication companies are top of mind, are also run mission critical apps. Without them, we're not able to use text messaging, whether it be WebEx or Zoom calls. They wouldn't be available to us. Remote working, as we've all been doing for a while now, would cease to exist. So if you really think about it, these mission critical applications touch almost every facet of our business and personal lives on a regular basis. If we look into who runs what these applications run on and the infrastructure types, we'll break it into a couple different areas. First, let's talk about servers. What used to be a standalone bare metal server that would run your OS types, typically OS types of Windows and your favorite version of Linux or AIX for open systems, in the mainframe case, ZOS. Those server resources now are being heavily virtualized and supporting tens or thousands of VMs and or containerized applications when you look at next gen apps or new age things, how things are being done now. Apps traditionally were basically built off of relational databases. But as we move forward and we kind of modernize things, we see that a shift from that to NoSQL databases, Mongo, Slack, and we see now more and more of Splunk, where that's being utilized to analyze a bunch of data looking for trends or anomalies. An example would be the performance anomalies where I can't afford that penalty, right? So if I can stay ahead of things, so be it. An interesting data point here is containers. Because containers, when they first came out, when you deleted a container, the storage that was tied to it, associated with it, was also destroyed. As these containerized applications become mission critical, That is no longer the case. And actually, the requirements on those storage are falling in line more and more with what they were for traditional applications, especially in the areas of storage persistence and availability. So let's take a look at what those requirements are. And there are 5 basic requirements, 5 key areas that we talk about. The first being an always-on architecture, think 0 RPO. Next would be, I need consistent, predictable performance. Again, can't miss my SLAs. Penalties involved, right? Trusted advanced security, this is top of mind these days. Whether it's protecting my data from the application all the way to the array, or actually making sure of only trusted people being able to manage my data sets or my storage assets themselves. The ability to consolidate without compromise. The scale at which we have to do these things, whether it's how many Microsoft Windows servers we're going to run, whether it's the size of the actual applications themselves, consolidation plays a key role in this. And we cannot compromise anything. And last but not least, these assets need to be effectively used as efficiently as possible, right? As critical as they are, I still keep an eye on my TCO, what it costs me to run these resources for these applications. Let's take a look at each one of these areas individually.
Sure. You know, I like consistent, predictable performance, but mission critical applications, performance has got to be, I would say, blazingly fast, and, you know, bandwidth of up to gazoo and that sort of stuff. You didn't have that on the list, though.
It actually is part of it, Ray. Thank you for the question. We'll get to that when we get to why we think it's so important, but you're absolutely right. If you look at the modern all-flash arrays, performance is key. The point that's going to be interesting that we'll show in a few seconds is the effect that data reduction can have on that consistent performance. So that's a key part of this. We'll get into that in a second.
All right, thanks.
No problem at all. Thank you for the question. So when we look at an always-on architecture that supports a 0 RPO, what do we typically mean by that? And first of all, for system resiliency, we think it needs to be a multi-controller scale-out architecture. And to talk about availability these days is top of mind. In an active replication scenario in a campus solution, along with a long-distance option, is also a requirement. So let's look at those a little bit more. The picture on the right does a pretty good job of depicting what we think a multi-controller scale-out architecture looks like. And the key components here are the high-speed, low-latency fabric and global cache that is accessible from all controllers that make up the system. This allows us to have a volume be accessible across all controllers with read-write access in a truly active solution scenario. Think ultimate high-end path redundancy. The other key component of this architecture is the fact that all of these controllers assets operate as a single storage array, which allows us to yield the highest IOPS and bandwidth, along with the response time that Ray brought up a few seconds ago, right? These key components are what we aim at when we talk about always-on architecture. So think system resiliency and highest levels of performance and bandwidth. When we talk about availability, we're being asked to support the highest levels of data availability with an eye on efficiency these days. And this is where active components are absolutely necessary. In the picture on the right, the top part of this depicts an active solution where replicas in both primary arrays are available for read-write access at all times. This is key because what's going to happen is if I stretch my application access across both my primary arrays, if one of the systems goes down, my application continues to run by accessing that same storage on the remaining primary array. So active. Key component of this, remember, consistent, predictable performance. So that needs to be in a campus type solution, correct? With synchronous replication between the two primary assets. In support of an out of region solution to to complete my DR picture, we actually use asynchronous replication to a third remote storage asset, and we manage which one of the primary arrays is responsible for updating that remote array. This gives us the ultimate in out-of-region DR solutions, while still giving us the active capabilities we need for these mission-critical applications. When we talk about consistent, predictable performance, to Ray's point, we talked about highest response times, talked about best-in-class and highest levels of IOPS and bandwidth. What we realized was we needed to integrate an artificial intelligence machine learning engine to optimize both the performance and the capacity efficiencies of the modern all-flash arrays. Let's look a little bit more into what we mean by consistent, predictable performance. And Ray, this might answer your question. Typical all-flash arrays, modern all-flash arrays, are very capable of supporting consistent, predictable performance, very low response times over a large amount of workload variation. That is seen here by both the yellow line and the light blue lines. Yellow line being another vendor's platform, the light blue line being our PowerMax platform. What we realized, though, was when we introduced data reduction into the environment, into the operating environment, the ability of the array to consistently deliver performance and predictable performance started having issues when the workload was increased.
So John, data reduction is compression, dedupe, thin provisioning. I mean, all that, or one?
Yes, that's correct. Right. Yeah. If you look at data reduction today, right? Initially, data reduction was basically about virtual provisioning, right, and thin savings. But more and more these days, the capacity efficiencies that are there that are required to make these arrays cost effective are going to be compression and dedupe, to your point.
Okay.
So yep, no problem at all. So as you can see here, as in some arrays, in some cases, as we turn on the data reduction and we start applying more and more workload to the arrays, you can see here the orange line, that what happens is my array's performance becomes inconsistent and unpredictable. What's interesting here is this. We're not talking about horrible response times. We're talking about multi-milliseconds. But when you're expecting consistently sub-millisecond response time, which is pretty much the norm from your storage arrays these days, this is not really acceptable. So by introducing an artificial intelligence machine learning engine built into PowerMax OS, we were able to knock that orange line down, and the dark blue line represents what we're able to show and support in PowerMax, which is the consistent, predictable performance that you're used to for the all-flash array, while still getting the capacity efficiencies of data reduction in the array. Does that kind of help with your line of questioning, Ray?
I understand the graph. So I mean, it's a relative response time on the vertical axis. I mean, so baseline would be like 1.0, and then in the orange case, at someplace there's it's I don't know 5x that is the kind of numbers.
That's in line with what we've seen. So if you talk to all of us, any platform out there, without data reduction, sub-millisecond response time is kind of table stakes, right? As you go along and you increase workload, everything's fine. Data reduction, though, sometimes can cause problems, right? Because we spend time looking to dedupe something, or we spend time trying to compress something, right? So what we've been able to do specifically in a PowerMax case is we look for the most access data, and we only apply data reduction to that only after we are under capacity pressure on the array. And that's what allows us to make this drastic change.
I got you. All right.
That's how it works. Next, we'll talk about advanced security, and we're kind of under the gun. We're about 15 minutes, so I'll try to keep us on schedule here. Whether it's data at rest or data in flight from the application to the array, top of mind these days, especially with malware being top of mind. Secure snapshots allow us to make sure that your backups and your snapshots on the array stay intact and can only be destroyed after expiration time. And secure access controls, RBAC is key to making sure that only people that should be allowed to can access the management tools of a system. End-to-end efficient encryption, exactly what I was just talking about. The ability to encrypt your data to protect it from the application all the way to rest on the array while still reaping the benefits of data reduction capabilities of the actual storage array itself. PowerMax OS. From a snapshot perspective, ZDP cyber recovery is an offering we have in our management software toolset for mainframes. You can see here scale is hugely important, right? As I said earlier, 32,000 volumes, snapping them every 5 minutes for the lowest RPO possible. Also having a 2-actor authentication security option to make sure that those snapshots are only managed by people you absolutely know. Call it the nuclear option, right? For management of this particular feature. And very quickly, secure snapshots. These snapshots, again, can only be deleted by PowerMax OS itself, and that's only after the expiration date that was set at time of creation has been met. This makes actually managing these secure snapshots very, very simple from an end user perspective. Kind of table stakes. Consolidation without compromise. I won't belittle this point because I think we've got some more interesting things to talk about here. But consolidation, hugely important. Support the OS types that I need for these mission critical apps. Also, the scale is hugely important, whether it be connectivity. I need X amount of connectivity for multipathing redundancy for open systems, as well as parallel access volume connectivity for FICON and mainframes, right? And we're actually also talking about levels of volumes when it comes to supporting things like VMware. Just as a note, just as an example here, I need a large number of volumes. For every VM that's going to be supported using vVols, I need four vVols. How many thousands of VMs multiplied by 4? That's going to be the volume count you're going to need to support all the vVols in that environment. Hugely important that we have the scale that we need. And snapshots, I'll go back to the ZDP cyber recovery thing I just described a second ago. Hugely important that we have enough snapshots to cover each of the applications requirements they need and support the RPOs they also require. Smart and efficient. Whether it be utilizing an artificial intelligence machine learning engine to maximize the performance while still giving you the capacity utilization effects of data reduction on the array. And just as important is offloading retired data sets or older snapshots to a cloud to lower my TCO of my actual storage. A little bit more about that very quickly. I'm able to, with cloud mobility, take snapshots of the array and push them up into either a public cloud with Microsoft Azure or AWS as examples, or a private cloud where we have Dell EMC ECS or PowerScale. These movements of these snapshots can be done using a policy-based system, and the data movement and management is secured and efficient using encryption and compression. A very quick reach out to the long-term retention capabilities that people are looking for these days. And we have the ability to actually reconstruct that volume in the cloud and associate CPU resources to actually go off and do some analytical work on that as needed. For more information on the PowerMax and why we think PowerMax is the array for mission critical applications, please visit the PowerMax product page at delltechnologies.com, and also look on YouTube on the PowerMax channel for different videos and demos of our product and feature sets.